All right. What we're going to do here, here's an example of how to find the center, vertices, foci, and eccentricity in the graph a sketch of an ellipse. And what we have here is a more complicated example on how to do this. Using all the information that we have right here is going to help us, or some basic information of how to sketch and find the center and different things of an ellipse. We have the basic standard equation, and then we have c squared equals a squared minus b squared, which is one of the major equations that will help us find the foci. Eccentricity, once again, is E equals the ratio of c over a, the foci length over the center to the vertices length, and that tells how much or how oval shaped the graph will be. So without further ado, let's find this equation. Now, in order to figure this out, all right, and find all these different characteristics, the first thing we want to do is we're going to write this in a standard form of equation of an ellipse. And obviously this is not. So to help us out with this, what we're going to do is we're going to separate all of our x values and y values in different columns. So right here, let's do this, okay. Sorry for getting everybody dizzy. But we have 9x squared minus 36x. We're going to have plus 25y squared minus 50y. And I want to subtract the negatives and put negative 60 on the other side because we're not going to use that right now. So we get all of our x's, all of our y's together. Now from here, what we're going to do is we're going to factor out and make sure that we have a coefficient of 1. Because now what we're going to do is what's called completing the square. So right here is an example of how we're going to complete the square. Complete the square. This is sometimes the most complicated part for students, but we got to do what we got to do. So we're going to take 9. We got x squared minus 4x, and we have this as our first part. Then we have, notice 25, so we're going to factor out a 25. Just so happens that 25 factors out perfectly, and what we get is 2y, and we still have negative 60 over here. Now from here, what we're going to do is we're going to figure out our c values. Okay, now the c values that we're referring to is not the c distance from the center to the foci. This is the c value of a quadratic. So to figure out this c value of the quadratic, I'll just put a little quad right here, all right, is we always take the b value, divide it by 2, and then square it. We have to make sure that this right here is always factored out. We have a coefficient of 1 before we do that, coefficient of 1, and that's some of the key things when you're going to complete the square. So in this case, what we're going to do is we're going to take negative 4, we're going to square it, or divide by 2 and square it, and what we have then is going to be 4. So we're going to add 4 here. Now, remember, whatever we do to one side, we have to do to the other, and also you have to make sure that you remember is that this 9. If we would distribute this back through, we didn't just add in a 4, we actually added in a 36. This is 9x squared minus 36x plus 36. So we're actually adding 36 over here and not just 4. All right, so 36, that came from taking 9 times 4. Okay, now let's find our next one. And for this next one, we're going to find this c value. We're going to take negative 2 divided by 2, then square it. And that's going to give us a 1. So we're going to add a 1 here. Once again, we're not adding just simply a 1 because we have to distribute this through to each one of the terms. So we actually have, it's not 1, but we're actually adding 25. So we're at 25 right there. I'm running out of room. Apologize. All right. We have 25 times 1. Okay. From here, give some more, little more space, is we're going to simplify this. We have this expression, which can then be complete the square, where it gives me x minus 2, that quantity squared, multiplied by 9. We have the 25 sitting there, and let's complete this square, where we have y minus 1, that quantity squared. All right, and that's all going to equal, if we add these together, we have negative 60, all right, and we have 25 plus 36, so that's going to be 1, 5, and 6, which is going to equal positive 1. There we go. What do you know? Nice and neat. All right, so from here, we have our equation. Now, this equation is not the one that we really, really want, because if you recall, we like it in the form where it's divided by a squared and divided by plus b squared. And there's no division here. So what we have to do is we have to create some divisions. So, and animosity. That's a bad joke. But what we have is 1 divided by 9. And we have y minus 1 squared. And once again, create some division. So we have 1 over 25. We're not really changing this. Okay, we're just rewriting it where we know that 1 over 25 actually equals 25 times the quantity y minus 1 squared. Same thing. All right, we just didn't reinvent this. We actually just divided where it is 1/9, which actually is the same thing as 9 times x minus 2 squared. That's going to help us because now it will allow us to identify what is the largest of the a values, all right, and b value. This is actually going to be something squared, so it's going to be 1/3 squared, and this right here is 1/5 squared. Now remember, the a value is always the largest of the values. And so what is the largest of the values? Well, we can obviously see that 1/3 is. So this right here is our a squared. And this one, because it's the lesser of the values, is actually going to be b squared. So from here, we can then identify a, when this is going to be 1/3, and b is going to equal 1/5. Nobody likes using fractions, especially me, but sometimes you got to do what you got to do. Now, from here, we're going to graph and identify all our vertices and foci and eccentricity and finish up what we have to do, what they ask us to do way up here. And don't forget, we did all this work just so we can start this process. So, using our equation, using the information that was at hand, let's look at and find our center. Well, we can find the center is located at 2, 1. So we're going to graph this at 2, 1. So we go 1, 2, and 1. And here's our center. So center, center is at 2 and 1. We can look at this and identify our major axis because this is a squared, the largest value. Our a squared is going to be horizontal. So I'm going to just draw an imaginary or major axis right here. Draw a dotted line for a major axis. And now we're going to find out our next values. Well, we can find our vertices. Our vertices are going to be 1/3 units away, all right, from our center. So our vertices is going to be very, very small. It's going to be a very small ellipse. I probably should have blown this up a lot more, but I didn't. Well, that's okay. All right. So to help us with this, we're going to find our vertice, and we're going to take our center, and we're going to move it 1/3, all right, 1/3 units to the right and left. So we're actually going to be adding something to our x values of our center. So it's going to be 2 plus 1/3, and the y value is going to stay the same, and that's going to be one of our vertices, which is going to be right here, about 1/3 unit away, right there. And if you want to take this, we could rewrite this as 6 7/3, 1. That's vertice 1. And we also have to go to the other side, so we're going to go 1/3 to the left, so we're going to subtract that from our value. All right, so V2, vertice 2 is going to be 2 minus 1/3, 1. Okay, so V2 is going to be 6 5/3, 1. Okay, just add those fractions. So, we have our two vertices. And now let's find our minor axes. So our minor axis, we're going to take 1/5, and that's going to be 1/5 away. So 1/5, so here's our, I should change this. This is our vertice. And now we're going to go up 1/5. Up 1/5 is going to be like right there and then right there. Very small ellipse. Very, very, very small. Okay. Looks like a very weird looking eye, but oh well. Now, from here, we're going to find now our foci, okay, our foci. Our foci are going to be c units away. So in order to find the c value, this is where we use our next equation. So we're going to have c squared equals a squared plus, sorry, not plus, Pythagorean theorem, minus b squared, all right, and that's how c is the key part we're looking for, because c is the distance from the center to each one of the foci. So from here, our focus. What we have here is we're going to have c squared. We're going to put in our a squared, which is, we know was 1/9. Minus, we're going to have 1/25. And this is not going to be nice at all. From here, we're going to add these together. We can find a common value. If you multiply 9 times 25, that's going to be 425. 225. 225. And we're going to have 25 here, minus 9 right there, and 225. All right, equals c squared. Very, very nice, isn't it? We're going to take 25 minus 9, okay, and that's going to give us a total of 16, 225, and that equals c squared. From here, we're going to take c and take the square root of 16 over 225, all right, and what we have then is going to equal 4 over, I believe, 225 is 15 squared. And then it equals 4 over 15. All right, so we're rocking and rolling. So now let's figure out what our next values are. So we're looking for this, and our foci, all right, are going to be right here at 4/15 away from our center. Wow. So they're basically like right there. You can see, basically I'm making like a little happy face. Not cool. But focus 1 is going to be 4/15 positive from the center. Now if you look at our center point, which is again is 2, so we're going to add that to 2. And our 1 is going to stay the same. Our focus 2 is going to be 2 minus 4/15 away from the center, and those are going to be our different foci. We can find our eccentricity, finally, by taking our c value, dividing by our a value, which is 1/3, and we have 4/15 times 3. Oops, nope, not times 3. Yeah, times 3, sorry. Times 3. And then it's going to be 5, so we have 4/5. All right, and that is our information. 4/5 is kind of close to 1, so it should be pretty oval shape. And we can have our different foci. Obviously, we can add those together, but I didn't feel like doing that. Why not? We've gone this far. Why don't I finish up? 15 is going to be 34. Over 15 to 1. And 30, this is going to be right here. 30 minus 4, which is 26, over 15, 1 is our other value. And with that, you can see that is what our value is going to be. So this was a little tougher one. A lot of work involved, a lot of bad fractions. Everybody loves those. Sarcastic, of course. But we found the center, we found the vertices, we found the foci, we found the eccentricity, and we also graphed this tiny, 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 itty bitty ellipse right there. Happy days. Okay. Well, I hope this helps you out, because this was a humdinger. And good luck and God bless on the rest of your problems. Let's see.